Okay, in this particular proof, we are given two triangles. And in these triangles, we are given that AC equals E, not EC, AC equals EG. So AC equals EG. And also AB equals EF, AB equals EF. So we have two sides of a triangle. And we have CD equals GH, CD equals GH. This happens to be the median of the triangle. We know that because it says that DH and H are midpoints of AB and EAF respectively. So from this line AB here, D is the midpoint and EF, H is the midpoint. Let me get another color so I can show. If those are the midpoints, then we know that EH and HF have to be equal to each other. Does that make sense by the definition of a midpoint? These are just some observations that I'm first looking at as I'm analyzing this proof. I'm just kind of saying, okay, based on the given, what do I know automatically? Well, it looks like this line has to be equal to this because D is a midpoint. See here? D is a midpoint of AB. And this line must have to be equal to this line because H is a midpoint of this line. Okay, so I've analyzed that. I see what am I trying to go for? What am I looking to prove? I'm looking to prove that triangle ABC, so this whole triangle here, is congruent to this whole triangle here, EFG. Now tell me, what are all the ways that we have learned so far in order to prove triangles congruent to each other? We can use theorem 1, which is side, angle, side. Side, angle, side looks like this. If I have two triangles, and I have one side congruent to one side respectively, and one angle in between congruent to one side respectively, and another side equal to another side, then I know that these two triangles are congruent. We proved that in theorem 1. So we can use side, angle, side congruent to another side, angle, and side in that order of another triangle. Another thing that we know angle, side, angle. Let's do that one. Angle, side, angle. Angle, side, angle. And angle, side, angle is theorem number... Theorem number 2, actually. Theorem number 2. Here, before that, I noticed up here we have corollary 1-1. And corollary 1-1 says if we have one leg of a right triangle congruent to another leg of a right triangle, then we have equal congruent triangles. So let me show you what that looks like. Here's a right triangle. There's my right angle. And here's another right triangle. Here's my right angle. And I want to prove that these two are congruent. Well, if I have this leg equal to this leg, and this leg equal to this leg, can you see how I have the same exact pattern as this? I have side, angle, side, side, angle, side. Because I know these are right triangles, I automatically have this angle equal. So leg, leg is another way I can do it. Unfortunately, we don't have any right angles here, so we know we're not going to use leg, leg. Then we have angle, side, angle, which is theorem 2. That one says if I have an angle, a side, and an angle equal respectively to an angle, a side, and another angle, like that, then I do have congruent triangles. And we've proved these in your notebook. You should have all the proofs for them. I'm just kind of reviewing what they are. Okay, so these are different ways we have. We also learned another one. We learned the corollary to this. Corollary 2-1, which shows that, well, what would you think? So we have an angle, we're just missing a leg and another angle. So this one is leg angle. And with leg angle, if I was to draw it with right triangles like that, see, I already have an angle, I just need a side and another angle. See that? Leg, angle. Remember this one's called the hypotenuse, the longest one is the hypotenuse. So we haven't learned anything about hypotenuses in this one. We do know leg angle is another way to prove two triangles congruent. But like we said before, in our original proof here, we don't have any right angles. So we're going to either do side, angle, side, or angle, side, angle. But there's another one that we learned. We learned Theorem 3. Theorem 3 is in any isosceles triangle, the angles opposite equal sides are equal. Do we have an isosceles triangle here? No, so that's not going to be anything that we need. I'm looking for side, side, side. Aha, theorem 4, okay. Theorem 4 says side, side, side. And honestly, you don't need to remember the names of these. I'm just doing that for reference for you. But side, angle, side, remember that. Angle, side, 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 leg, 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 angle. Those are all different ways that we have learned to prove triangles congruent. I need to know them. Okay, so this one says, if I have 2 legs equal and 3 legs and all 3 sides equal respectively to all 3 sides of another triangle, then I have 2 congruent triangles as well. What do you think? Let's see, is there any corollary to that? There is not. Okay, so those are the ways that we have learned, the 5 ways that we have learned how to prove triangles congruent, except for this one. We also learned move through space is a way. We're not going to need to move through space in here. Let's just try a few different things. Notice here we have a triangle and we're trying to prove the big triangle is congruent. We do have a side and we have another side here congruent based on our given. So here's what I'd like to try to do based on our given there. I'd like to get angle A equal to angle E, because if we get angle A equal to angle E, then we have side, angle, side, respectively, congruent to side, angle, side. And then we can use theorem 1 to prove that these 2 triangles are congruent. Well, in order to get this angle, angle A and angle E equal, is angle A and angle E part of any other triangle? Yeah, we can see it's part of ACD and EGH. And notice we can get side, 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 and side, side, side to be congruent in both of these triangles. So let's try that one. I am recording a video, Joey. It's okay, you can be in here, it's just for my class. Okay, so here's the proof. Statements, reasons, okay, 1, this is our given, always, and our given is AC is equal to EG, AB is equal to EF. Hi, Mrs. Gutierrez.
Hey, Linda. Are you at home or in the dorm?
I am at the AC at the moment.
Okay. Is Teresa down there too?
I think she's at the... No. I believe that she's in the dorm.
She's in the dorm. Okay. Ring the doorbell, but like I said, she wants to help you in the dorm.
Okay, do you just want to get in the garage?
No, we got the treadmill machine, the mattress up there, and I forgot about that, so we need to grab that.
Go for it. I think it... Is she not answering her phone?
She's here.
Oh, okay. Okay, bye.
Okay, bye.
Sorry about that, but we got the given written. Okay, so reasons or statement number 2. And honestly, guys, you can do this however you want to. It doesn't have to be in a certain order. But like I said when we were analyzing it, I'm thinking to get this side, 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 and then after that, I'll have side, angle, side. So in order to get these 2 triangles equal to each other, I need to start with some kind of statement about these halves here. Because I wrote that in pink because it wasn't part of our given. It's something that we need to prove that AD is equal to DG, or DB. But can I prove that? Yeah, well, the definition of a midpoint says, and we'll look it up right here. I think I have them all defined in my book. You should have them as well. Midpoint. Under M. Alright, a midpoint. The point that divides a line segment into 2 equal parts. So if it divides it into 2 equal parts, then they must be equal. So I'm going to say AD equals DB, and also that EH equals HF. And that is by the definition of a midpoint. Again, you could have started with something else. That's just what I decided to do. Okay, following this logic now, we've got these parts equal to each other. Well, let's see. I would like those parts equal to the whole because I know I want to have them in the same statement. Okay, let's work from the bottom going up again. Just in case someone was to get stuck. If you didn't know what to do after this or you're just kind of stuck, let's work from the bottom up because that's also usually a really great way to do a proof. Okay, so I'm going to put step 10 down here. I don't know what number it's going to be, but we can fill in as we go. That doesn't really matter, as long as we're corresponding it. Okay, step 10 we know is going to be our very last step, and it's going to be what we're trying to prove right here. Triangle ABC is congruent to triangle EFG. And that is going to be by side angle side. That's what we said. We said we want to do side CA. We have that over here, AC, is equal to EG. And we have already that AB is equal to EF, AB is equal to EF. So we just need angle A equals to angle E. So in order to get this, we need angle A equals angle B. So in step 9, I'm going to put angle A equals angle B. We're planning to get that by CPCTE of these two triangles here. So that's going to be my reason. CPCTE. Remember, CPCTE stands for corresponding parts of congruent triangles are equal. And corresponding parts, so angle A and angle E, these would be corresponding parts of these two triangles, can only be equal if we have already proven congruent triangles. So in step 8, we will have to have proved the triangle that these are part of. And we're trying to prove triangle ADC congruent to EHG. Triangle ADC is congruent to triangle EHG. ADC, EHG, this one, this one. Okay, and we're trying to prove that because of side, 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 side. So you can see, already here, I'm filling it in quite a bit. Oops, side, side, side. There we go. Okay, in order to get side, 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 the only thing we're missing from our given, because we have this and this, we're just missing side AD and EH. So on 7 here, I'm going to say AD equals EH. And I'm not sure how I'm going to get AD equals EH. That's what we're working from up here to try to figure out how can we get AD equal to EH. Well, so far here I have AD equals DB and EH equals HF. My goal is to try to get this into one particular equation that shows all of those letters in the same thing and see if I can make it look like this. Alright, here's what I was suggesting. We know the whole is equal to the sum of its parts. So AD plus DB, let's do that. AD plus DB has to equal to AB. We know that for sure. We also know EH plus HF is equal to EF. The thing that stood out to me, oh wait, first, what's our reason for that? Sum is equal to the whole, so whole is equal to the sum of its parts. Does anyone remember what axiom that is? That would be axiom number 6. Bonus points if you remember that. Okay, 4. Okay, 4 is, now that we've got these kind of here, when I was thinking, I'm like, okay, I want to get AD equals EH, and I want these guys to match. We do know something about AB and EF. Up here in our given, it says AB is equal to EF. So could I write it like this instead? AD plus DB is equal to EH plus HF. Yeah, that would be true because of substitution. Equals, these two are equal, and this is equal to this, and this is equal to this, and this is equal to each other, so then these must be equal to each other as well. So you can see like a little vertical equal sign here, so there must be a vertical equal sign right here as well, technically. Okay, this is by the substitution axiom. Does anyone remember which one that is? substitution axiom. That's axiom number 8, just in case you'd like to look that up. Okay, and now, let's see, we've got this and this and this and this here. We know that AD is equal to DB. We know EH is equal to HF, so why don't we just write their equals in place of here? Because I'm trying to get to this. I'm trying to get from here to this. I want AD and EH just by themselves. So let's do that. Step 5, AD plus AD equals EH plus EH. Is that logical to you? That I can substitute this for this if they are already equal up here? That should be logical. Equals, so I can substitute the equal for its equal. Again, that's the substitution axiom right there. Okay, number 6. Woo, we're getting really close. And this one just happened to be 10 steps. If not, you could do like 6.5, 6.6. But I see the missing step between here and here. Look at this. AD plus AD is equal to 2AD. EH plus EH is equal to 2 EHs. 1 plus 1 is 2. 1 plus 1 is 2. 1 AD plus 1 AD is 2 AD. 1 EH plus 1 EH is 2 EH. Okay, look at this. If we have here, oh, this is just addition, basically addition. If we have 2 ADs are equal to 2 EHs, can I get this? Really, really easily. Watch. Just divide by 2. Divide by 2. And then you have AD is equal to EH. So 7, we know now this is division. Division. And there we have it. We have proved, going from both sides, that those two triangles are equal. Give you a good picture overview.